Hello everyone and welcome to today's session on electric vehicle design process at IntelliPath. Do you know friends that every great innovation starts with an idea and electric vehicles are no exception. They are built to head into a sustainable future, removing the rate of carbon emission happening on the roads. The process of manufacturing these vehicles begins with the designers and the engineers brainstorming various concepts to create an electric vehicle that aligns with the needs and desires of the people. Initially, they consider questions like what type of electric vehicle would best suit the urban environment that promotes eco friendly commuting? Or how can we design a rugged electric SUV that appeals to the adventure seekers and the outdoor enthusiasts? These queries guide the team as they lay foundation for a vehicle that will impact the lives of countless people worldwide. Then we move to the research and development. After we have achieved a clear vision, the next process is to gather data and research. Engineers and designers analyze existing electric vehicle technologies, batteries, and motors while keeping an eye on the latest trends in the sustainable materials and energy efficiency. So you can consider asking questions like what materials do you think would be ideal for building the body of an electric vehicle? After this, we move to the prototyping stage, where skilled designers leverage advanced computer aided design software to create virtual representations of the vehicle. This virtual canvas allows them to experiment with various shapes, sizes, and contours until the perfect design emerges. Let's see an example. We all know that aerodynamics play a vital role in the efficiency of an electric vehicle. So engineers meticulously assess the airflow patterns and make precise adjustments to minimize the drag, thus optimizing the vehicle's range. This process may involve countless iterations, each taking them closer to the ultimate electric vehicle form. Once the virtual model is refined, it's time to bring the design to the life through physical prototypes, through testing and validation. The testing and validation phase is crucial for ensuring the electric vehicle safety, performance, and efficiency. Engineers conduct crash tests, evaluate range, acceleration, and top speed, and also analyze energy consumption. Real world simulations are also performed at this stage, which helps to identify potential weaknesses. Extensive road test is also performed, which ensures the vehicle meets real life driving expectations. This rigorous process guarantees that electric vehicles meet the highest standards, assuring customers of a safe, reliable, and eco friendly driving experience. After rigorous testing, we move to the battery and powertrain integration. We all know that the heart of an electric vehicle lies in its battery. At this stage, engineers optimize the battery's capacity, weight, and cost effectiveness while experimenting with advanced battery chemistries and cell configurations to extend the vehicle's range. Simultaneously, they design the powertrain for efficient propulsion, considering single or dual motor setups, front or rear wheel drive configurations, and all wheel drive options. The goal at this stage is to harmoniously unite the battery and powertrain to create a dynamic driving experience while maximizing energy efficiency, thus empowering electric vehicle to perform at its best and pave the way for sustainable mobility. After battery and powertrain integration has been done, we move to the next step in the design process, that is interiors and user experience. At this stage, the interior and user experience of an electric vehicle are carefully designed to provide comfort and convenience. Ergonomics play a vital role in ensuring seamless driving experience. Designers focus on creating an intuitive dashboard layout with an easy access to the essential controls and information. Infotainment systems are integrated to offer connectivity and entertainment, thus making journeys enjoyable. Additionally, charging solutions are integrated into the interior so that there is a hassle-free access to the charging ports. At this stage, engineers aim to create an inviting and user-friendly experience while maximizing energy efficiency.
Hello, hello. Good evening, guys. How are you? I hope you are well and keeping safe. Hello, can you hear me?
Hello, good evening.
Oh, great. Okay, perfect. I can hear you. Okay, okay. Okay, Okay. Yes, so welcome to our orientation webinar on electric vehicle design hackathon. My name is Willie Jackson and I work with Green First Technology. We are having this in partnership with Afribot Robotics. Yes, so at GFT, we've been working on two projects. We've been doing one electric truck, terminal tractor for port operations, and we are done with that. So we wanted to move to the next project, that is doing last mile deliveries at truck, and also a town car, a concept close to Voxy, for those who were able to do research online. So I'd like us to just do a quick round of introduction before now I introduce our team at GFT. We have, okay, so we could start with Kiprui, Brian, Milton. So just unmute your microphone, tell us your name and what you like doing. That is, so this should not take more than 5 minutes. Yes, Kiprui, hello.
Hi.
Hello, yes.
Hello everyone, good evening. My name is Brian Kikurui. I work with Mazi Mobility, an EV startup, majorly dealing with two-wheelers. I'm a hardware engineer at the company. Yeah, that's all.
Thank you so much. Milton? Hello? I think you're on mute, Milton. Okay, Newton Zuki.
Yes.
Yes, kindly. Okay, Maguta Cyprian.
Good evening.
Yeah, good evening.
I'm Moguta Cyprian. I specialize in controls and automation engineering. Industrial plants whereby I deal with PLCs, programming, and also maintenance activities. Thank you.
Yeah, thank you so much, engineer. Can see Laura's not taker, so I guess that's AI. Keep Krui, oh, that's also AI. Eugene Gusmo.
Good evening, everyone. I hope you can hear me.
Yes, we can.
Hello, everyone. My name is Eugene Gusmao. I'm a fourth-year mechanical and manufacturing engineering student at Multimedia University of Kenya. And I really love the whole concept of research because I believe it's a perfect platform of knowledge gaining. Thank you.
Thank you so much. JOKS. Joka. JOKAS. Yes, kindly. Okay. Bruce Tibet. Bruce. Bran Gillo.
Hello, good evening.
Good evening.
My name is Brian Gillo. I'm a final year software engineering student with an experience in industrial creative design. Yep, thank you.
Okay, thank you so much. Kennedy Odeo.
Hi everyone, good evening. I'm Kennedy Odeo. I'm an electrical and electronics engineering student at Kenyatta University. Currently, I'm in my final year, and my interest is in embedded systems.
Thank you so much, Ken. Joseph, Nick. Joseph, Nick. Okay, Ian Lagat.
Good evening, everyone.
Good evening.
I have a background in electronics and computer engineering at University. Currently practicing I'm an enthusiast, and I saw this opportunity as a very good opportunity to experience my design in systems and signals, power signals, and even maybe powertrain. Thank you very much. I wish to learn more from this hackathon.
Thank you so much, Ian. I can see Jokas, your hand is up. Kindly proceed.
Yes, hello. Jonathan is my name. In full, it's Jonathan Kasumba. I am an automotive designer and glad to be here and to take part in this. So in this case, I won't really be presenting, but I'll be glad to see what is going to be shown. And it's lovely to see that such an initiative is happening out here. That's all.
Thank you so much, Mr. Jonathan. Mm-hmm. So, Nicole Kesare.
Hi, everyone. I'm Nicole Gesare. I'm a second year mechatronics student at Dedan Kimathi University. Pleasure to meet all of you.
Okay, nice to meet you too. Abraham Mora.
Hello, good evening. My name is Abraham Mora. My background is in biomedical engineering with a niche in computer-aided design and embedded systems programming. At some point, I ever did some work with Gogo Electric in Uganda, and I truly believe that the future is EV and battery-powered systems, and I'm very excited to take part in this initiative.
Thank you so much, Abraham. Isaac Masinde.
So hello, evening. My name is Isaac Masinde. I'm a final year student at Moi University taking mechanical and production engineering. I'm glad to be part of this team.
Thank you so much. Hilary Jerega.
Good evening, everyone. I hope you can hear me. My name is Hilary Zarega. I graduated TUK, Bachelor of Engineering, Aeronautical Engineering, in 2023. Last year, I was on an internship at Kenya Airways, and I'm joining this because I really like EVs. I like car design, and I'd like to bring the technologies, especially in space and aeronautical, to this side as well.
Okay, thank you so much. I'm not sure if I've skipped someone. If you've not done, maybe if you Brian Macharia, kindly proceed.
Hello, good evening.
Yes, good evening.
My name is Brian Macharia. I am from JQuat, currently taking mechatronics engineering. I'm in my fourth year. And I like robotics. My main interest is in robotics.
Thank you so much. I guess we have all introduced ourselves. Someone has just joined. Right to, oh, Warren Munene. Okay, kindly, if you not introduce yourself, kindly just unmute your microphone and introduce yourself. Kindly proceed, Munene.
Hello guys. My name is Warren Nene. I'm let's say design engineer. I graduated last year from the Technical University of Kenya, and I'm happy to be here.
Thank you so much. Okay, so I'd like us to proceed. I can see we have Engineer Pius from GFT. We also have Engineer Bran and Jashon. but he's not here. So maybe you could introduce yourself, Jashon. You can use my computer. And then Pius, you'll use yours. Bran, you can use Pius' computer. So we'll start with your end, Engineer Pius kindly. So just your name, your role at GFT, your name, your role at GFT, and yes, anything else you'd like to share with us. Asante, back to you.
Okay, thank you very much. Hello, good evening, everyone. I am Pius Macharia, and I work at GFT, Greenfields Technology. I am in the Department of Mechanical Design, and I'm happy today to be here to I look forward to seeing your ideas in the world of electric vehicles. Thank you very much.
Thank you so much, Engineer. Bran?
Yes, hello. I'm Bran Amtali. I'm a mechanical engineer at GFT, and it's a pleasure to be part of this meeting. Thank you.
Thank you so much. Yes. Okay, so just one more member, Engineer Jashon. Okay, so after a round of introduction, we'll move straight to see your designs. This meeting is to last just 1 hour. So by 9:00, we should be done. Today is just more of an orientation day. So we just wanted to see how many of you managed to attempt the design. And then from there, we'll give you general rules, what we expect from you. And then tomorrow we'll gauge if we can have at least a few winners, number 1, 2, 3. Then will communicate on what next. Hopefully, we want to see these solutions produced by the end of the year. So by the end of the year, we need to have a physical product prototype funded by GFT. So just a second. Okay, Joshua, you ready? Yeah. Yes.
Okay, hello. I'm Joshua Masala. I work with Afribot Robotics as an electrical engineer. And I look forward to seeing your projects as you bring them forward. Thank you.
Asante sana, Joshua. Yes, so I guess we were all able to access the design rules. It was just simple, but I could share my screen so we could just walk through them quickly before we start the presentations. I hope you can all see my screen. So we have 62 members, participants who signed up, and around 30 teams, because some of them had double entry. So the design, we had two categories: the last mile truck and the urban mobility vehicle. Okay, so the innovation and creativity will be awarding 30 marks in total. Then practicability and also feasibility around 20. Energy efficiency and sustainability 20 marks. Safety and adaptability 15 marks. Then your presentation and teamwork will account for 15%. So with that, I'd like to, okay, we won't have an order of presentation or presenting, but in case you're ready, just let me know so I can allow you to share your screen. We just want to see, everyone will have like 2 minutes each to talk about their design and also just show us what you're able to come up with. It doesn't have to be perfect right now, but we just want to see those who have managed to attempt something. So we can use the chat section. So just let me know, just type your name on the chat section. If you like to go first, then we'll use that order. Just type your name on the chat section and of the teams that will be presenting. So if you have a group name, just type your name there, your members, and then the name of your project and category. Then we'll use that order for presentation. Again, this should take the shortest time because I know, yes, we have 25 here, around 20. So if you allocate like 2 to 3 minutes for every team. Today we are not judging anything. We just want to see what you are able to come up with. I can see Bruce, your hand is up. Kenley, you have a question?
Yes, I have a question. Are we presenting slides?
Sorry, I can't hear you. Yes, I can now hear you.
Are we presenting slides or just the design, or how are we presenting?
Oh yes, just the design. The design.
Oh.
Yeah. Okay. Yeah, so I can see number one, we have Brown Masharia, Areas EV Urban Mobility. Please write the name of your team members as well. If you are doing this as a team, yes, you can also do it as a solo. But if you did it as a team, please list all your team members on the chat. Then with that, okay, with that said, we can have Brian. So the rest keep sending on the chat section, on the in-call messages, then we'll use that order. So kindly, Brian, proceed. You can share your screen to share with us your design.
Good evening, everyone.
Hello.
So I was tackling urban mobility, and in this case, I was designing six passenger, so 7-person but 6-passenger um, vehicle in the shape of a minivan. Let me just share my screen. So my design stage took um, so there are 2 phases in my design. First of all was the drivetrain design, and then there's a card model design. For the drivetrain, I decided to use MATLAB, and MATLAB simulating to design my vehicle. This so I used MATLAB to enable me to have the rates or the parameters such as the battery capacities, the motor power that I require, and then all other details such the vehicle you have to have. The vehicle is designed for 250 kilometer range, and it uses regenerative braking. So first of all, I'll take you through the MATLAB design. So I only modeled for the drivetrain only consists of the vehicle model, then the transmission model, then the motor, and then the battery. And in this case, the battery is also attached to a regenerative braking model, so it recharges when the vehicle brakes. Then for the simulation, I used FTP75. This is a standard in the US. So it has about a distance of about 17.77 kilometers for about 2474 seconds. So for this produced the following graphs. So this was the that I got from the simulation. The maximum motor torque in this case is about 150 newton meters. The motor speed required to be about 5,300 RPM. And then for the motor power, then this requires to a maximum of this is 50 kilowatt motor in this case. And then the battery is also modeled, and its sort of state of charge is also modeled in Simulink. So this is without regenerative braking. I added regenerative braking later, and I'll just show you. So with regenerative braking, you can see that some points go higher than. So at these points, you have the battery charging for the braking power in that case. And then for the actual card model design, I used a combination of Blender and SolidWorks. But for the rendering, I used mostly Blender. And this is sort of what the car looks like. This is general shape. So as I said, it has 7 seats, 1 for the driver, and then 6 for the passengers. And then it's designed to have sort of an old car design blended with the futuristic design, with sort of large windscreen and then also large windows in this case. And then to use the outlook is also the inner car design. Yeah, so this is the drivetrain model. This is a single rear wheel drive, and then the battery also has implemented heat sinks on the bottom of the battery to enable more efficient cooling for the battery. So I think 2 minutes are up. So yeah, that's my design for now. And over to the design.
Yes, thank you so much, Brown Masharia, for the great presentation. Actually, when you started presenting, I thought you didn't have the card design. I was about to ask you, what about the card design? Yeah, so thanks a lot. Yeah, that was great. Again, today we are not judging, so other participants, you have time to iterate your design to make it better, better, and better. Yes. So next we'll have. Oh, okay. Who would like to go next? We'll have Team Safari, Loft EV. They're working on urban mobility as well, like Bran Gilo and Opamen Sogi. Okay. Yes. Can you proceed? Yeah. So I'm just curious, Mr. Brand. Oh, your part. Okay. Okay. Can you proceed? Oh, can you confirm? I think you are on mute, Mr. Brand. We can see your screen, but we can't hear you.
So the left of it is powered by full electrical system, enhanced by cutting-edge solar technology in its roof. So the vehicle features an array of high-efficiency solar panels known for their sleek design and superior energy conversion rates, making them a popular choice for electrical vehicles. So as you can see up there, the top. So what we place the solar panel so that in terms of it's like additional power source to extend the vehicle range and reduce reliance on charging station. So this is our front side. The exterior, we've reimagined it. The exterior is more like a sleek prism glass with an LED strip covering it. So that's it. Wait. So you're trying to create a stylish kind of a electrical vehicle cab. and it's for bustling cityscape, aesthetic, functional, whether you want to commute or more of like an Uber. So the best thing with the left EV, you can see these two parts here, this front seats can rotate easily, giving you kind of a stylish or comfortable chill ride. So the best thing also, the glass from exterior, the natural sunlight when it hits it gives kind of a warm mood. So, yep, I think that's all. Thank you.
Thank you so much. Do you have the mechanical design somewhere?
Can we share it tomorrow?
Okay, no worries. Okay, sawa. That's okay. Thank you so much, Mr. Newton. That's some great work. I liked it. Same as Mr. Brand's work. Thank you so much. So next we'll have Engineer Pius, can you take note? Team Safari, Love TV, there are two, Brand Gilo and Oba Sogi. The first presenter, Brand Macharia, is working solo. Yeah. So next we'll have Eugene Gusmo, Hyperion Vehicle Model, and also solo. Okay. Yes, kindly proceed.
Okay. First of all, thank you for this opportunity for presenting my project. So I think I'll now proceed to share my screen. The only thing that I'll be presenting today is the CAD design, although I'm not yet fully done with it, but I really wanted you guys to see the aesthetics behind the model itself, behind the Hyperion model itself. So let me just share my screen. Okay, I hope you can be able to see my screen.
Yes, we can see it.
Okay, so what I was really going for with the Hyperion model here that we have is the aesthetic value, its efficiency, and also its sustainability in terms of energy. So mine is an urban mobility car, a car that is designed to be able to move. Within the urban areas, being able to carry passengers from one given area in that urban area to another area. So as you can be able to see, this is the model in how it looks like. So yeah, so these are the windows. What you can see here in blue, it's the solar panels that we wanted to fit at the top so that it can be able to support the vehicle's energy intake, other than having the EV system in place to be able to support the vehicle's movement and everything. We figured that if we can be able to input the whole aspect of solar panels, it can be able to support the whole aspect of energy. If you note the shape, it also supports the whole aspect of aerodynamics in regards to being able to maneuver the streets effectively, as you can note by the shape. We also plan to fit our design with the sort of like detachable doors in such a way that based on a person's presence near it, it can be able to go up and down in such a way, promoting efficiency during passenger intake and during the time in which they're able to drop off the passengers. As you can be able to note at this particular point, as you can be able to note at this particular part here, this is the lighting system that will be turned off during the night period, whereby the driver can be able to move around during the night hours and everything. So as you can be able to note from our system, we wanted to create a vehicle that first of all can be able to participate actively in the aspect of reducing carbon emissions. That is where we were able to fit the solar panels. In its telemetric system, we are hoping that it can be able to incorporate some aspects of AI, so that it can be able to assist in matters such as route tracking and determination, so that it can be able to help the drive in regards to movement within the urban setting, and ensure that passengers are able to be dropped off at the correct destination. So this is the design and how it's supposed to look like. I know you're noticing that we can't really be able to see the wheels, but we've been able to design the model in such a way that the wheels are sort of like covered, so as to reduce the whole aspect of wear that may arise. And also another thing to note with our system, the material that that I was able to consider in regards to coming up with this system is aluminium. I considered a way in which we can be able to create a lightweight vehicle. That can be able to support the vehicle's maneuverability from one given area to another effectively. So I'd like to go to the benefits of having the lightweight concept that we also want to introduce into the vehicle's body. So first of all, when you talk about the vehicle being lightweight, it promotes the whole aspect of improved fuel economy, whereby you realize that with its lightweight system, it's both strong, but it's able to consume less power. Thus, it promotes the whole aspect of better fuel efficiency. It also leads to enhanced performance, since it will become more responsive and easier to maneuver. It also assists in the whole aspects of lower carbon emissions, since you do realize that it doesn't really require much power to be able to move from one given place to another. So this is this is my design. Yeah.
Thank you so much. Thank you so much, Mr. Eugene Gusmo. Thank you. Okay. So again, you are a solo presenter. Okay.
Yes.
Thank you so much. Okay. So I'm reminded to balance those who are doing the town car and the track. Is there anyone doing the track last mile? So okay. If not, we can proceed to. We can proceed to Team Imara. Warren Munene, futuristic urban public transportation.
Yes. Thank you. I'd like to request if the next team, Team Asili, is ready. They could present. We're trying to sort out some issue from our end.
Oh, okay. Thank you. Yeah. So, keep crew, Bran, kindly proceed. Team Asili. Small urban mobility.
All right. Let me just share my screen. I hope you can see my screen. Yes. So our team, I'm just going to play the video. Just a second. Yes. So our team, these are basic a small compact 4-seater EV car, And basically, we're just finishing the functionality part. We are supposed to finish now on the aesthetics and looks. But basically, I'm just going to go a bit on about what really makes up the car in terms of drivetrain and a bit about safety also. So it's a 4-seater, small compact, 3 plus the driver, and some few safety features, including LiDAR, as you can see at the top. We have LiDAR, we have adaptive cruise control, we have lane keeping assist, autonomous parking, but yeah, so I'm not really going to open up the car because this is part of the slides we had prepared. So I'm just going to go through the design features. So in terms of energy efficiency, it has a solar panel roof, specifically to support or aid in battery charging. It has also a regenerative braking enabled hub motors. The hub motors are front mounted. This is the design of the hub motor. Basically, the motors are inside the wheels of the front wheel, and in the middle we have the battery. The battery is made up of three modules, and the modules basically the battery has a rating of 35 kilowatt hour and an approximate range of 250 kilometers of range. It has a DC charging with a maximum capability of up to 52 kilowatt hour fast charging DC. And in terms of efficiency, it is able to do in terms of per mile per kilometer consumption. It's around 100 watt hour per kilometer consumption of energy. And motor, as I've said, the motor mounted at the front wheels. It's hub motor. Each motor is rated at 12 kilowatt motor and top speed of 120 kilometers per hour. Yeah, so basically that's the basic features of our car. Our team is now focusing on designing, focusing on the aesthetics part. Yes, so that's all about our Asili car. Yeah, I think I'll stop for there for now. Thank you. Hello.
Okay, thank you. This was okay, thank you, Team Asilu. I think Warren was supposed to be next. You can proceed, Warren.
Yes, we can proceed. So let me try sharing my screen first. So our project is called Project Imara. As we were designing this project, we aimed at really emphasizing on the sustainability aspect, long-termness of the project. So my team members are currently not available, so I'll be sharing. Okay, allow me not to share the design for now. So we have designed a bus. Okay, looking at our current situation in the transportation sector, we noted challenges mainly being accessibility and the manufacturing practices that are used in producing them. So our design aimed at increasing accessibility, especially to PWDs. PWDs meaning not only people with wheelchairs or crutches, but also the blind and deaf through various technologies that are incorporated within the bus, such as braille surfaces, audio cues, and also ramps to enable people with wheelchairs to easily get into the matatu. We haven't yet come up with another name other than the normal term that we used to refer to it. So that's our main design philosophy, designing for sustainability and ease of manufacturability. Also, in terms of safety, we enhance safety by using multiple materials within the chassis design to enhance the effectiveness of crumple zones. So we use a blend of structural steel and aluminum. In terms of sustainability and the materials we use in manufacturing, we try avoid using a lot of virgin material. We, like for the braille surfaces, we propose using recycled plastic, recycled HDP mostly. That's what we have come across. And in terms of also effectiveness in how much time is spent on the road by the car, because when a car is stationary, technically it's losing money. We've incorporated vehicle to grid technology, charging systems such that they are still in the experimental phases in other countries, but we believe the same could be integrated within Kenya if at all the necessary infrastructure and there is political goodwill, of course, in researching such. So we are also looking into battery swapping technology as a solution in buses and also vehicles. So those are some of the things that we are looking into. We shall see the design. I don't know when. I wasn't technically prepared to present the design today. So that's like call for action for any other time I'm doing such a project. Thank you.
Thank you so much, Mr. Warren, for the presentation, taking us through your project. Asante sana. So I hope by tomorrow you'll be able to show us a design prototype, yes, and also maybe get a chance to introduce your team. Next, we'll have okay. Okay. Anyone else who would like to share with us the design? Because I can see we've had we've had five presentations. So five. Yeah, so far we have 0 participants on attempting the last mile track. There's a group that told me that they are doing the 2 challenges. I'm not sure which one. Oh, again, I know there are so many other participants who have missed this call. So tomorrow we'll be meeting the same time. 7 from 7. So we'll share with you the meeting details and everything. I'd like to open it up for Q&A. Anyone with any question, if you need us to clarify on something, kindly feel free to ask. Then now your questions will inform my response. I can see Mr. Gilo, your hand is up. Just kindly. Okay.
Yeah, Mr. Jason. I wanted to you clarify more on the aspect of the mechanical aspect in terms of the mechanical design. What do you expect?
Okay. Yeah. So for us, already we've done the electric track from design to fabrication to the software that is running and monitoring. And there are some challenges that we experienced in house. And yes, so we are really willing to work with you the journey from your idea stage to bringing that prototype to life. Yeah, so our expectation is a design that is beautiful, sleek, and can be fabricated locally. So locally doesn't mean that it has to be ugly, because I believe we have all it takes to produce a world-class robot or car, semi-autonomous car, or truck for those who are doing the track. Yeah, so something we can fabricate locally with the local talent. So if you can design it, then we can always assemble a team to bring it to life. So yeah, so we expect just something good, innovative, and of course we have the rubrics on the Google form. So innovation and creativity is like 30% of the mark. Practicability is 20%. So that 30 plus 20 is already half. Now the other things, energy efficiency, those ones we can always work on together, and sustainability, that's 20%. Safety, around 15%. And then how you present teamwork, that is 15%. So that's our expectation, Mr. Gillo. Okay, thank you so much. Any other question? Bran, yes, kindly.
Thank you for the opportunity. I just want some kind of clarification regarding tomorrow. Maybe can you share the breakdown of how things will run tomorrow so that we know how to prepare and what to expect during the meeting? Because I understand this was a pre-run of tomorrow. So just for the teams to make sure they are fully prepared, what is it that you're expecting tomorrow?
Pius, did you hear that? Pius Pizza. Okay. Thank you. Yeah, so tomorrow we expect you to, because what we are interested in is the design, okay? Design. So PowerPoints, yes, they're good to see, but we want to see the design. So just use your favorite software to do the presentation. If it is SolidWorks, just have it opened on SolidWorks and now use it to present. We just received a text from the director of GFT. So I'll read it for you. So a design, so spare parts design and manufacturing. So a vehicle with as few spare parts as possible. Then good suspension and stability, safety, security, and aesthetics. Of course, we've talked about that. So it should look very, very beautiful and minimum parts if possible. Yes, something we can always fabricate here. So I can see your hand is up, Mr. Bruce. Kindly proceed.
I wanted.
Sorry.
No, we don't use slides at all. If we have the design, we just open the software and we don't share it.
Yeah. You just open the software and start presenting. Just tell us these are like the first presenter. Was it the first presenter? The one who there's one who presented the different parts and the assembly and so on, so on. So something like that. So if you can do it in that way, how the parts are modeled differently and assembled into one, yes, and with good aesthetics. Yeah, you don't have to use your PowerPoint. Already we know why we need green, why we need EV in terms of carbon emission and so on. So already we know those ones. So what we need is just the design.
Oh, and when we are presenting, do we, if it's a team, is it one person presenting or do we all have to present?
Oh, yeah, sure. So you see in a team, yeah, we encourage teamwork. So you can always give your other members other areas to present, also to showcase their prowess. Yeah, so we highly encourage teamwork. Again, I know there are those who are shy, but you could mention their contribution when presenting as well, if they're not able to speak. Yes, Mr. Brian.
Hello. So you've mentioned that there's points for presentation and teamwork.
Sorry?
You've mentioned that there's points for presentation and teamwork. So
there's no need for?
There's points.
Oh, yes.
So I was wondering, for solo designers, the teamwork part affected. Is there any penalty for working solo?
Oh, yeah. So presentation is around, presentation quality is around 15%.
Yeah.
So which teamwork also is key. So teamwork means that you are able to bring people together and work out a project. If you're designing as a solo, maybe there are those components that you had to consult other people to help you with, though they were not able to be part of the project. So you could just let us know how teamwork also contributed to your project. So you don't have to have a member, you don't have to plant someone to make you score that mark. If you can get the other marks and a few marks on teamwork, but then we highly encourage teamwork. Because you see, when we move to fabrication, when we move to now bringing this product design to life, you'll be working with a bigger team. So how will you be collaborating with the other members from electrical, electronics, mechatronics, software? Yeah, so teamwork is key. But you can mention how you engage the different people on your design. Thank you. Any other question? Yes, Mr. Warren.
You said you had worked on the electrical part. So is it flexible to adapt to the design, or is it rigid such that you would only take people who fit into your category?
Oh, okay. Engineer Jason will take that one.
Okay, we've worked on an electrical system for electrical track, yes, but suppose just bring in your design. We are flexible. As long as you can convince us that your design is working much better than what we have, much more efficient and all that. So if you can support your design work, we'll incorporate it. So just do your electrical work. If you decide to do it as well, you are allowed to do that.
Thank you, engineer. Yeah. So, Mr. Yeah, I can see Jokers, your hand is up. Kindly proceed.
Thank you very much. So I hadn't presented today, but is it okay if I could present tomorrow?
Oh, yeah. You can present tomorrow. Yeah, sure. Mm-hmm.
And another thing is, I would be working together with also another person. So we are a team.
Oh, okay. Okay.
Yeah.
Great. So just remember to send me on WhatsApp. For those who are not able to present today, just remember to send me more details about your team on WhatsApp. That's my number. So if you're not in Kenya, you could add 254 before the 7. So you remove the 0.
All right. Cheers.
Thanks. Any other question? Yes, Brian Kirui.
Just a follow-up on a statement made by one of your team members.
Yeah.
As convincing that our design is better than the one you have. So in terms of reference, what are we really, because now it's very hard to know like what the team did achieve at that specific point. So doing a reference point to our design reference, comparing our design to what the team achieved is a bit difficult. So maybe kind of elaborate more on that.
Okay, so as I've said, you're doing a research. As much as you are designing the mechanical part, you're doing a research on your own. You're seeing whatever is out there, what people are using. So if you find that you can go ahead and use whatever is available, you go ahead and use it. But if it is a challenge, if you find it is a challenge that people are still facing and you feel you have something better, you have the calculations to support it and documentations and all the references to support your work. That's what I mean. Whatever we have currently, we have a functional electric truck. It's a terminal truck. Yes. It has a complete system from the mechanical to electrical. Yes. So in your case, the truck, whether you're designing the truck or whether you're designing the one for the passengers, if you feel you are going to work on an electrical part, just work on it. Don't leave it out. Whenever you're present, tell us why you are doing this. What are people using out there? I believe you know how research works. You see what's available in the market, then you can either decide to use whatever is available in the market, or if you feel that you can do something better, then you go ahead and put in the feature that you are going to put. Then you can come and support it. Why did you decide to go that direction? Was it because of cost, performance, or any other reasons that you can bring into the table? So that's what I mean by just bring your design. Then you'll convince us that whatever you have is better than what's already out there. Is your question answered to your satisfaction?
Yes. Maybe another follow-up question to another follow-up question is, how many minutes are we going to be presenting tomorrow, Martin?
Thank you, Mr. Brand. So each team is going to have a maximum of 10 minutes for presentation. Yeah, so 10 minutes. So you'll have 10 minutes to do the presentation. Again, you can do everything on your design software unless it's really necessary, but we just want to see it on the design software. Thank you. Any other question? Any other question from the participants? Again, there is one category that has not been explored: the terminal, the last mile track. So, if we won't have a good quorum tomorrow, we may postpone that category to a later date. Because we can't have a walkover. If we only have one participant or just two participants, less than 5 participants, then it will be unfair even to us to be able to judge a few people. So we may give you guys time. You finish this one, the EV design challenge. You get the winner. Then we prepare properly for the last mile track. Any other question?
Mr. Jason, for the in terms of the presentation, can you not limit it based on the software used? Or if I can do it PowerPoint more, both the design of the mechanical design and the design itself of the semi-autonomous car.
Okay, limiting on based on the software used. We definitely have to have a maximum set time that you can present with, because leaving it open based on software use, maybe someone might say that this is unfair because we use this software now, we are limited to this much time, and someone says the other thing. So as you've been told, you'll be given a maximum of, say, 10 minutes. Now you can work on your project, prepare for the presentation, see what points you're going to drive forward to make you stand out within the 10 minutes. Because if we leave it open, then it's going to take quite a long time. Is that right, Justin? Yeah. Brian, you have something?
Okay, I'll try, but if I can I maximize on the 10 minutes using the PowerPoint presentation?
Maximizing using the PowerPoint presentation. Yeah, if you feel that using PowerPoint presentation is going to drive your point forward, then you go ahead and present that way. You've been given what is required during the presentation. Now you just organize yourself, then use whatever you're going to use. You've been told what is expected. Now, how you present it will be up to you. We won't victimize you for the method you use. We are only looking for the end product and the most suitable product during judging. Yeah. So does that suit your needs?
Okay. Yeah. Yeah. So,
Thank you.
yeah, sorry, I was on mute. Okay, apologize. Yeah, so Mr. Gillo, that's okay. Assuming your project was on SolidWorks or Fusion 360, you could export your design to slides or Canva, and then now walk us through that. So again, it has to be an original design. So that's okay. So you could maximize where you feel your strengths are. Any other question? Okay. Thank you so much, guys. Looking forward to meet you tomorrow. In case you have any doubts, I've shared my contact on. You can WhatsApp me any question between now and tomorrow. I wish you all the best, and yes, kindly tomorrow remind your team members to attend the meeting. Bye bye for now. See you tomorrow.
I was thinking like what to model for this workshop. It was like a 5 days workshop with the students and for beginners of Blender. So I was looking for a car which is not so complicated, but also not like super simple like a Volkswagen Up or something. I wanted to have some air intakes and outlets. And I was thinking, okay, I really like Lamborghini Gallardo. And this year, I mean, last year, it was like the 20 years anniversary of the car. So I was like, okay, let's make a Gallardo, but not the existing model, because as a designer, my goal is not always, my goal is never to model existing cars. So I was thinking, okay, we can use it as a reference, but let's change some parts and let's kind of design it like a homage version of.
So my name is Maina Karanja. I'm a student from Knight International School, year 13, and I've been sent to Afribot to complete my 2 weeks internship course. So what I've seen in Afribot is that it's the perfect mix of both hardware and software. So it's, I would say, the only acceptable case of a polygamous relationship, given that it's a mutual yet beneficial relationship between mechanics, electrical engineering, and software engineering. Here we've had the chance to have a taste of all three fields, and it's been quite enjoyable so far. We managed to install the batteries just recently. The connection is almost done. Test running should start around a week or two from now.